Welcome, everyone. I'm excited to kick off today's presentation on construction. This is the first slide, so I just want to warmly welcome you all and thank you for being here. The title of our presentation is simply Construction, and we'll also touch on some key aspects along the way. Over the next few minutes, we'll explore the fundamentals, the latest trends, and the challenges in the construction industry. So let's get started and dive into this fascinating topic. Let's move on to slide 2, which is about basic construction. Here, we'll focus on the fundamental techniques you'll need to construct triangles accurately. These basic methods are the building blocks for more complex geometric constructions, so mastering them is crucial. We'll explore how to draw angles, bisect lines, and connect points properly. Understanding these basic steps will help you confidently approach any triangle construction, especially when given specific measurements or conditions. Remember, these foundational skills are essential for the entire process, and they connect directly to the overall theme of understanding and applying geometric principles effectively. Welcome to this introduction slide. Here, I want to emphasize the importance of setting a clear foundation for our discussion. We'll go over the key points thoroughly, but I'll make sure to keep it conversational and engaging. As we explore these ideas, I'll highlight the most critical concepts, ensuring they stand out. Connecting these points to the overall theme of our presentation is essential because it helps us see how each part fits into the bigger picture. My goal is to make this both informative and easy to follow, so let's dive in and explore these ideas together. Let's talk about constructions in geometry. These are essentially drawings of various shapes, but with a specific twist. We only use a pair of compasses and a straight edge or ruler. Now, what's really important here is that we do not measure lengths or angles with any tools like a protractor or a ruler. Instead, we're relying solely on the tools for drawing, not measuring. In geometry, the word construction has a very precise meaning. It refers to creating lines, circles, and other geometric figures purely through these drawing tools. This approach emphasizes understanding the properties and relationships within shapes, rather than just measuring and copying lengths or angles. So, as we move through this presentation, keep in mind that these constructions are fundamental because they help us explore and prove geometric concepts in a pure, elegant way, using only our tools, no measurements needed. This method sharpens our understanding of the underlying principles of geometry. Let's take a closer look at the basic construction aspects. When we talk about construction in this context, we're referring to the fundamental principles that ensure a structure is safe, durable, and efficient. It all starts with understanding the key components that make up a building, from the foundation to the roof. Each part plays a crucial role in supporting the overall integrity of the structure. It's important to grasp how these elements work together, the materials used, the design considerations, and the construction techniques. By mastering these basics, we set the stage for more advanced concepts and innovations later on. This foundational knowledge helps us appreciate not just how things are built, but why they are built a certain way, aligning with our overall goal of creating reliable and sustainable structures. Let's delve into the basics of construction today. First, an angle bisector. Think of it as a ray that cuts an angle exactly in half, creating two equal parts. It's like drawing a line that splits a corner into two perfect mirror image angles. Next, we have the bisector of a line segment. This is a line that cuts the segment into two equal halves, ensuring each part is just as long as the other. It's a straightforward way to find the midpoint of a segment. Then there's the perpendicular bisector. This line not only divides the segment into two equal parts, but also intersects it at a right angle, making it perpendicular. This concept is especially useful in many geometric constructions and proofs, as it helps us locate centers and symmetries within figures. Overall, these tools, angle bisectors, segment bisectors, and perpendicular bisectors, are fundamental in constructing precise geometric figures and understanding the relationships within them. Let's walk through how to construct the bisector of a given angle, specifically def. First, we'll focus on the initial step. Using point E as the center, we draw small arcs on both rays ED and EF. The key here is to make sure these arcs intersect the rays at points that are conveniently spaced, as they'll serve as reference points for the next steps. Next, we look at where those arcs intersect the rays. Let's call those points G and H now. With centers at G and H, we draw 2 more arcs with the same radius. The purpose of this is to find a point where these new arcs intersect. We mark that intersection as point I. Moving on to the third step, we draw a straight ray starting at point E and passing through point I. This new ray is actually the bisector of def. It divides the angle into 2 equal parts, which is the main goal of our construction. So, to summarize, we start with the arcs from E, find their intersections, then use those points to create intersecting arcs to locate I, and finally draw the bisector from E through I. This process is precise but straightforward, and it beautifully demonstrates how geometric constructions can help us divide angles accurately. Let's walk through how to construct the perpendicular bisector of a given line segment. We'll start with our segment PQ. The goal here is to find a line that cuts exactly through the middle of PQ at a right angle, which is what we call the perpendicular bisector. First, draw the line segment PQ. This is our base. Now, for the next step, we use a compass. With P as the center, draw an arc on either side of PQ. Make sure the radius is more than half the length of PQ. This is important because it ensures the arcs will intersect. Next, without changing the radius, place the compass on Q and draw 2 arcs that intersect the previous ones at points R and S. These intersection points are crucial because they help us locate the exact midpoint of PQ. Finally, simply join points R and S. The line RS is our perpendicular bisector. It cuts through PQ at a right angle and exactly at its midpoint. This method is a fundamental construction in geometry because it helps us find centers, midpoints, and create perpendicular lines efficiently. Remember, the key here is the use of arcs and their intersections to accurately locate the midpoint and perpendicular line. Let's look at how we construct an angle of 60 degrees at the initial point of a given ray. Here, we start with ray PQ, where P is our initial point. The goal is to draw another ray, PR, that makes a 60-degree angle with PQ. First, we draw the ray PQ. This gives us a clear starting point. Next, we focus on constructing the 60-degree angle. With P as the center, we draw a small arc that intersects PQ at a point C. This arc essentially marks a reference point along PQ. Then, we use C as the center and draw another arc with the same radius, intersecting the previous arc at D. This step creates a point D that helps us measure the 60-degree angle accurately. Finally, we draw the ray PR from point P passing through D. This completes our construction, and we see that the angle RPQ is exactly 60 degrees. This step-by-step process ensures precision and helps us understand how to construct specific angles geometrically. Vamos falar sobre a construção de triângulos, que um tema fundamental na geometria. Para começar, é importante entender que, ao construir triângulo, precisamos de certos elementos básicos, como lados e ângulos. A partir dessas informações, podemos determinar as demais medidas e formas do triângulo. Por exemplo, se temos 2 lados e o ângulo entre eles, podemos usar essas informações para construir o triângulo com precisão. Além disso, existem diferentes métodos de construção, como usando régua e compasso, que garantem exatidão do resultado. Esses métodos são essenciais para garantir que nossos triângulos estejam corretos, especialmente quando trabalhamos com problemas mais complexos. E, claro, ao construir triângulos, estamos desenvolvendo habilidades de raciocínio espacial e precisão, que são importantes para toda a geometria. Então, entender bem esses processos de construção nos ajuda a compreender melhor as propriedades e as relações dentro dos triângulos, que são tão presentes em muitas áreas de matemática e de vida cotidiana. Now, let's talk about the construction of triangles. A triangle can be constructed when you have specific sets of information. For example, if you know the length of the base, one of the base angles, and the sum of the other 2 sides, you can determine how to build that triangle. Alternatively, if you know the base, a base angle, and the difference between the other two sides, that's also enough to construct the triangle accurately. Additionally, in some cases, knowing the perimeter and two base angles allows you to construct the triangle as well. The key idea here is understanding which pieces of information are sufficient to uniquely determine a triangle's shape and size. These construction methods are fundamental because they show how different known data points can be used to recreate the triangle precisely. This ties back to our overall theme of understanding the relationships between sides and angles in triangle construction. Let's go through the process of constructing a triangle when we know its base, a base angle, and the sum of the other two sides. In this case, consider triangle PQR where QR is our base, with length, centimeters. The angle at PQR, which is PQR, is given as x degrees. Additionally, the sum of the other two sides, PQ and PR, is b centimeters. Now the steps start with drawing the base QR of length, a cm. This forms the foundation of our construction. Next, on a line extending from Q, we mark an arc S such that the distance QS equals b cm. This is crucial because it sets the total length of the two sides we're working with. Then, at point Q, we draw the angle XQR equal to x degrees. This helps us establish the correct orientation for our triangle based on the given angle. Following that, we draw the perpendicular bisector of segment RS. The intersection of this bisector with the line QS gives us point P, which will be the vertex opposite the base. After locating P, we connect P to R, completing the triangle's side. Finally, by joining P to R, we complete the triangle PQR. This construction ensures that all the given conditions, base length, base angle, and the sum of the other two sides, are satisfied. Now, let's briefly look at a similar approach, but for when we know the difference between those two sides instead of their sum. In triangle ABC, with BC as the base of length, a cm, angle B as x degrees, and the difference between sides OB and AC equal to b cm, the construction involves similar steps. The key idea here is understanding how knowing either the sum or difference of two sides, along with a base and an angle, guides us in accurately drawing the triangle. This technique is fundamental in many geometric constructions and helps us visualize relationships within triangles clearly. Let's walk through the process of constructing a triangle when we know its base, a base angle, and the difference of the other two sides, specifically in the case where OB is greater than AC. First, we'll start by drawing the base BC, which we'll label as a centimeters. This forms the foundation of our triangle. Next, we make an angle at point B, denoted as XBC, and set it to x degrees. This angle represents the given base angle that helps us determine the shape of the triangle. After that, we mark a point D on the ray extending from B in the direction of our angle, such that the distance BD is equal to b centimeters, which is the difference between the two other sides. Then we connect point D to point C, forming segment DC. This step is crucial because it helps us position the other sides correctly according to the given difference. Next, we draw the perpendicular bisector of segment DC. The intersection point of this bisector with the ray from B gives us point A, which is vital for ensuring the sides are correctly proportioned. Finally, we join point A to point C, completing the construction of our triangle ABC. This process ensures that all the given conditions, base angle, and difference of sides, are satisfied, resulting in the precise triangle we need. Let's walk through how to construct a triangle when we know its base, a base angle, and the difference between the other two sides. This is specifically for the case where side OB is shorter than side AC. First, we start by drawing the base BC, which measures a centimeters. This gives us the foundation of our triangle. Next, we move to step 4 and draw a line segment DC, which will be important later in our construction. Then we make an angle at point B, labeled as XBC, equal to x degrees. After that, we extend ray BX in the opposite direction to prepare for the next steps. In step 3, we mark a point D on this extended ray BX so that the distance BD equals B centimeters. This step is crucial because it incorporates the difference of the two other sides into our drawing. Following that, in step 5, we draw a perpendicular bisector of the segment DC. This bisector will intersect the extended ray BX at a new point, which we label as A. Finally, we join points A and C, and just like that, ABC is the triangle we need to construct. Throughout this process, the key concept is how we use the given measurements and angles to accurately position the points. The perpendicular bisector helps us determine the correct location for A, ensuring our triangle has the specified properties. This method highlights the importance of geometric tools and reasoning in solving construction problems. All right, now let's look at how we can construct a triangle when we know its perimeter and two of its base angles. This is a slightly more advanced problem, but it's really important because it combines different aspects of triangle properties. The key idea here is that knowing the perimeter gives us a total length, while the two base angles help us determine the shape of the triangle. From these angles, we can find the third angle since the sum of all angles in a triangle always adds up to 180 degrees. Once we have the angles, we can use the law of sines or law of cosines to find the side lengths, depending on what information we're given. And because we know the total perimeter, we have an additional constraint that helps us narrow down the possible side lengths. So the main concept to remember is that by combining the perimeter and angles, we can uniquely determine the triangle's side lengths. This method is especially useful in practical scenarios where you only have partial information, but need to find the complete shape. This approach really highlights how interconnected the properties of triangles are, and how understanding these relationships allows us to solve complex geometric problems efficiently. Let's walk through the steps to construct triangle ABC when we know its perimeter and two base angles. The key here is that we have the total perimeter, which is the sum of the sides AB, BC, and CA, and we also know angles at B and C, which are x degrees and y degrees respectively. First, I draw a straight line XY that measures the entire perimeter, a centimeters. This will serve as our baseline for the construction. Next, at point Y, I draw a ray YM that makes an angle of y degrees with XY. This helps us set the direction for one of our sides. Then, at point X, I draw another ray XL that makes an angle of x degrees with XY. This gives us the direction for the other side originating from X now. At this stage, I focus on the angles inside the triangle. I draw the angle bisector of LXY, which divides that angle into two equal parts. Following that, I draw the angle bisector of mix. The two bisectors will meet at a point A, which becomes an important vertex of our triangle. Connecting this point A to points B and C, which we will determine next, will give us the sides of our triangle. To find points B and C, I draw the perpendicular bisector of segment X, and where it intersects XY, I mark B similarly. I draw the perpendicular bisector of segment AY, and where it intersects XY, I mark C. Finally, I join points A to B and A to C, completing the triangle ABC. This construction ensures that the perimeter and the angles at B and C are correctly represented, forming the triangle we set out to build. Let's wrap up with a quick summary of the key points we've covered. Throughout this presentation, we've explored the main concepts thoroughly, but also in a conversational way to make them easier to understand. I've highlighted the most important ideas to keep in mind, especially how they connect to the overall theme of the presentation. Remember, the goal is to see how these pieces fit together and apply to your work or projects. So, keep these insights in mind as you move forward, and always think about the bigger picture. In this final slide, I want to highlight the key points we've covered in this chapter on construction using ruler and compass. We've learned how to bisect a given angle, which is fundamental in creating symmetrical and precise constructions. We've also explored how to construct a triangle when we know its base, a base angle, and the sum of the other two sides, which helps in solving many geometric problems. Additionally, We saw how to draw the perpendicular bisector of a line segment, a crucial step in many constructions involving symmetry and midpoint identification. We also looked at constructing a triangle given its base, a base angle, and the difference of the other two sides, expanding our ability to work with various known measures. Another important construction was creating an angle of exactly 60 degrees, which is often used as a building block in geometric design. Lastly, we learned how to construct a triangle when given its perimeter and two base angles, combining multiple pieces of information to achieve a precise figure. Throughout this chapter, the common theme has been mastering these fundamental tools to solve diverse geometric problems with accuracy and confidence. These constructions form the foundation for more complex geometric reasoning and problem solving, connecting everything we've learned to the broader scope of geometry.